Welcome to Energy Talks, the podcast where we take you behind the scenes and talk to the people powering the energy sector. This week, I'm joined by Alex Haynes and John Carpenter, where we're going to be talking all about hydrogen. What's the biggest topic going to be in 2023, and will it disrupt the energy landscape? So sit back, grab a cup of tea, coffee, and enjoy this conversation. Alex, John, thank you so much for joining me here today. And today we're going to be talking a bit about hydrogen.
Awesome, great to be here. Thanks very much.
Thanks, Darren.
Yeah, thanks for joining us. So I'm going to start with the big question first. So it's been a lot about, we've talked about colours and that, but I feel like that's over now. So what do you think is going to be the biggest topic in hydrogen in 2023?
I think I can start by saying getting some projects actually into delivery. It's almost been a bit of a kind of phony war for the last couple of years. There's been lots of talk, lots of MOUs, lots of bits of kind of engineering and concept work. We've been doing a lot of kind of concept pre-feed, feed engineering, but the projects haven't actually got into that delivery phase. So I think the topic of conversation this year will be very much how do we get these projects really moving, get them through FID, start putting some concrete and steel in the ground, and then the challenges that all of that will start to uncover when we start building these things out for the first time.
Yeah, I completely agree. We have to start building these things. It's too much talk. It's the fuel of the future. There was John and I always laugh. There was a joke at COP 27 in Egypt where someone said to the interview, "I'm sorry, I couldn't hear your question, but I know the answer is hydrogen." And I think that sums up the last couple of years quite a lot. There's so many blog posts and MOUs and discussions, but no one's actually producing anything yet. And we need, if we're going to get to net zero, and hydrogen is one of those energy vectors that we think is useful, then somebody's going to have to start producing it in a low carbon or zero carbon way and actually have people use it. And hopefully we're on the forefront of that in some of our projects here in the UK and globally.
So what do you think is going to make, what's going to turn the tide? What's it going to, people say, right, we've done the talk, and what is going to make them tip the balance now to actually get into delivery?
So I'll talk about there's one bit which is really helpful, and then I think Alex will pick up the baton on some of the kind of financing side. So governments have a really key role to play in the energy transition in general. So the technologies that we're looking at are new. We haven't done this before, and particularly we haven't done this at the scale that we need to do it. We need to change the whole kind of energy infrastructure of the planet in about 30 years to have any chance of getting us to net zero. So governments have got a really important role to play in kind of catalyzing that. So, particularly developed Western kind of governments putting down funding, putting down incentive mechanisms or taxes, kind of disincentives to get this thing moving. So in the UK, in Europe, in America at the moment, we're seeing schemes come into play. The Inflation Reduction Act in the States, the new Green Deal that just came out a couple of days ago in Europe, that will start to put funding into these projects, make these projects kind of economic and provide that kind of underpinning so that they can actually start to get this away. So I think that's one really big thing we need to see to get this going. And once you start getting some volume into the market and there's more kind of understanding of how it works, then there'll be more comfort. And then other projects that maybe don't have that in some other markets will hopefully be able to get away as well. But then the other problem is what do you pay for this stuff?
So the government regulation helps, right?
Yep.
Because that can often, with grant and subsidies, that can often help set that price. But we're seeing smaller projects, maybe not the big export projects, also struggling in understanding what their long-term offtake price should be. So if you're setting up a project here in the UK and you want an offtake for 15 or 20 years, what price do you pay for that hydrogen in 2035? What's the market rate? And because it's a new energy vector, it's not easy to estimate. And we've had clients who've gone out to two different professional services that will estimate the price and come up with two different answers. So how can you then negotiate your long-term agreement with your offtaker if there is an agreement on what that value is? And there's so many unknowns on the actual cost of gas, the cost of energy, whether there's a premium for it being green or if it's a different color, or what level of carbon it's got in it, depending on taxes. So it's proving very challenging. Where we're seeing these projects go quickly is when it's displacing an internal fuel source. So where you're using fossil fuels, and you want to displace that directly with green hydrogen or low carbon hydrogen. Then you can make that decision if it's relatively small scale as a business depending on your ESG goals, your shareholder value, maybe your first mover in the market as a premium because you're selling a green product as opposed to a grey product. And I think that's where we'll see those first movers go quickly, where they can control that long-term pricing internally.
What do you think are the main challenges associated with the widespread adoption as hydrogen as an energy source? What can Petrofac do? What can industry do? And what's really holding us back?
Hydrogen is not a silver bullet, right? It's one of a number of routes. Whether you use it for transport, and there's lots of debate about that, right? It's going to be, we're heading towards a fragmented energy system. So we've been spoiled, right? We've had this one solution fits everything, isn't it wonderful? And it has been, a great driver of economic prosperity. However, the backstory is it's also driven climate change.
Yeah.
So how do we keep that energy price down? How do we keep it accessible for everyone? There's still billions of people on the planet who don't have access to any kind of energy, heat and light for their homes, so they can study. Their kids can study at night, or they can heat their food. So how do we? I see a future where there's many different routes for low carbon energy, and a little bit like the cell phone revolution, where large parts of Africa didn't get phones because the copper lines to go across to that small village or that inland piece wasn't worth the cost. And then suddenly everyone had a cell phone, and it was relatively easy to get access to phones. In fact, we've all got 3 or 4 these days, right? Everyone has more than one. So I think you can find this fragmented, bespoke, and it's horses for courses, or you find a energy solution that works. So if you've got access to a geothermal resource where you can produce energy that way, then that might be the cheapest thing for you. It might be solar, it might be solar plus a battery, it might be solar plus wind, and then in some industrial areas it might be ammonia, large-scale ammonia import, or large-scale wind import. And I think we've got to get out of this habit of looking for the one solution. And actually, the great thing is there's so many solutions now, and there's more coming all the time that can be almost bespoke to that area that can then be used globally. So I think you're going to see a wider range of different energy sources from a more fragmented, rather than a central hub and spoke model. You'll have this sort of cellular model, and frankly, I think that's going to give us more resilience. Because you can have multiple backups and multiple forms of energy coming into you. Actually, I think it's a really good part of the mix, but it's not the only part. And I think we need to be cognizant of that.
And just going back to, where does it make the most sense to use hydrogen? Well, it's displacing the hydrogen that's already there. There's already a kind of 1 million tons a year of hydrogen used in refining, in petrochemical, in kind of hydrotreating, hydroprocessing, in fertilizer. That's probably the other kind of major use today. So if we can just decarbonize all of that, that's probably 1.5–2% of global emissions straight away, and it's displacing exactly the same molecule. It's just a lower carbon version of it, which is just fundamentally the best thing to do. Most of the other applications do need some upgrades, whether it's a drivetrain in a truck or a train, or a boiler tip in your boiler at home. There needs to be some kind of upgrading to make use of the hydrogen. But just on that, one of the other drivers we're starting to see is also around energy security, that resilience that hydrogen can give you as an alternative fuel source, particularly with everything that's kind of happened in the Ukraine. We're starting to see clients really waking up, and this is obviously a big driver for Germany, for example. How can they get energy from another source? And hydrogen, particularly if you can transport it around as ammonia or methanol, allows you to bring in electrons effectively from places in the world where they've got lots of great renewable resource, and then transport those electrons in the form of hydrogen or its derivatives over to Europe, where they're fundamentally short of energy. And that's going to be, I think, a big driver kind of going forward. It's not just the decarbonisation, which is fundamentally required as well, but energy security is becoming a much bigger driver of this too.
You're seeing this huge build out of wind in Europe. Certainly in the UK, and you've got ScotWind and all the rest of it, and actually far more wind energy can be produced, probably will be produced, because you're going to have overcapacity for the days that aren't windy. Right? So if it really is a windy day everywhere, then the UK grid's going to fall over quite quickly, and we'll have excess electrons. So, and the same in Europe. Right? So if you can get everything electrified that makes sense to be electrified close by, then that's the most efficient way of doing it, and you're not paying the energy penalty of changing into a molecule. But then there will be certainly days, and I forget the number for curtailment in the UK alone last year, but it was billions or trillions worth of
billions of pounds worth of
curtailment, where they just shot the energy into the ground, right? Because we couldn't use it in the grid. Well, if you've made that investment and you can quite simply use that excess electricity and store it as hydrogen, then that makes a lot of sense. And then if you can use that hydrogen locally to where you're making it, so you avoid the energy penalty of transportation, that also makes a lot of sense. Yep. So it's going to be an iterative process, but as John said, economic drivers and greed will push us forward, and where there's an opportunity, I've got this asset or these electrons that at the moment I'm doing nothing with, what could I use it for?
Yep.
And then suddenly you start to produce hydrogen locally, and then it goes to the local bus service or local garbage trucks, whatever it might be, or the taxi firms. And you can suddenly make a buck or two on it. That makes a lot of sense. And I think you're going to get, as I said before, this fragmented approach where you get this sort of energy resilience and layering of different sources, which again is good news. Right? It should honestly make it cheaper.
Yeah.
For all of us consumers.
We've really moved on wind, and Petrofac's been part of that for over a decade now. So it's nice to hear that, like, you see these two coming together. It's not just, we've missed a boat because we've gone electric, but these hydrogen actually can almost act as a glue around it to cover all the gaps as well.
Cheapest forms of power anywhere in the world today are some of the solar plants in Saudi and the UAE. They're talking about, I'll do it in pence or cents, but it's kind of 1.3 cents a kilowatt hour. That's a phenomenally low price. So the more of that you can build out, that starts to unlock really interesting things. The challenge, of course, is the sun's only on during the day, and the wind blows when the wind kind of feels like blowing. But this is one of the advantages of hydrogen. You can turn, when you've got too much wind or sun, or you kind of overbuild, so you can build a bit of extra capacity. You can turn those electrons into hydrogen. You can store that for longer periods of time, much better than a battery. And then either use that hydrogen, which Alex was saying is the best thing to do with it, but if you need to, you can turn it back into electrons when the wind or the sun, when the wind's not blowing or the sun's not shining at the end of the day. So it's going to be a mix. As I said, oil and gas is going to be a part of that future. We need to decarbonize that as well. So whether that's carbon capture, kind of on the back of those facilities, so we can capture some of the emissions. But there's a huge amount of work to do there, and hydrogen is going to be very much right in the middle of all of that.
Yeah, it seems like the opportunity is there. It's just how do we capitalize on that? And so we've mentioned it all. So what's the main opportunities at scale for hydrogen? How far does it go? I know we've said it's a supportive one. How far can it go as an energy source?
Yeah, it's a really good question, and to a degree it depends on the different applications you see for it. When you look at the research, you said the energy transition is going to have lots of different solutions. It's not just hydrogen or just carbon capture. There's going to be all of the above, plus biofuels, plus electrification. So it's kind of, where does it play in the mix? And it's back to, where's the hydrogen the kind of most optimal solution? So we said displacing grey hydrogen in refining petrochemicals, kind of fertilizer is the obvious place to start. In some of those hard to abate sectors, we can see it as a really good use case. So things like shipping. Today ships are burning fuel oil. Some of the more modern ones are kind of burning LNG, but there's fundamentally an emission associated with all of those. One of the use cases for those excess electrons we're seeing in very windy, very sunny places, so kind of Western Australia, Chile, Namibia, Oman, is actually converting that hydrogen into ammonia or methanol, and then burning that ammonia or methanol in the ships, and then using those ships to move the ammonia and methanol around, so that kind of hydrogen, those electrons, are able to be moved across the world. Again, shipping is 2.5% of global emissions, so that's a very material sector, and one that you need a zero carbon fuel to be able to mitigate that some way. And certainly ammonia can be a zero carbon fuel. And as someone was pointing out last week, particularly ammonia, it's almost infinite in how much we can produce. there's 79% nitrogen in the air, and there's we've got loads and loads of water on our planet, fortunately, and there's a lot of sun and wind and geothermal that we can go after. So you put the combination of those things together, and you've kind of got an unlimited supply of ammonia. And again, ammonia we can use as a fuel in engines. You can actually burn it in power stations as well to create electricity. So there's lots of, other than as ammonia in the fertilizer industry, there's lots of other good things you can do with it too. It's a bit different to handle, but there's we understand that it's not like it's a completely new molecule. And those projects, to get the economies of scale in those, we were talking about the cheapest solar, but those solar fields are kind of 1.5-2 gigawatts a pop. That's a really big solar field. We're talking about thousands of square kilometers for some of these projects. We're doing gigawatt scale projects in offshore winds now. We're seeing multi-gigawatt scale projects coming around Europe. And then, if you want to convert all of those electrons produced into hydrogen, we're talking about multi-billion, dollar projects at the end of the day. These are as big, if not bigger, than some of the biggest things we've done in oil and gas, but actually with no less complexity. It's a slightly different makeup of the complexity. Half the project is renewables. It's producing electrons from the solar and the wind. And then the other half of the project is turning those electrons into some molecules and then kind of doing something with them, whether that's shipping or whether that's putting them into some other process at the end of the day. The potential as a market is huge, and certainly the potential for Petrofac is really big as well, and something we can see a really good use of all of our skills and experience to kind of play into almost immediately.
We're seeing hydrogen as a feedstock into SAF as well.
Yeah.
So sustainable aviation fuels. And again, if you can't use the hydrogen locally, then if you can combine it with some CO2, which there is plenty of, either biogenic or we're seeing it from cement plants or other emitters, and you can start to produce these e-fuels. So whether it's e-methanol or SAF. So again, a bit like replacing the grey hydrogen refinery, you can replace it in a new process. And there's a huge demand for SAF. Hydrogen planes, yes, I'm sure they can work at some point, but there's a lot of debate about that. But if you can use that hydrogen and mix it with CO2 and other to create the aviation fuel, well, we know exactly how to use that, because it's a drop-in fuel. It's a complete replacement. You can price it. It's much easier, and there's huge demand from the airlines as they try to decarbonise. Everyone's going on holiday in the year or business trips, whatever it might be. So I think there's value to it there as well, and that's why I think that hydrogen question, where is it being used, it's going to sort of sort itself out, because the highest value use for it is where it will go.
What makes Petrofac a good fit to drive these initiatives?
We've been dealing with hydrogen molecules in refineries for well over a decade now. We've been separating CO2 from natural gas streams for probably 3 decades or so, particularly in the Middle East. So we understand both of those molecules. And then, as you said, in the last kind of 10-15 years, we got into the offshore wind space. So actually, we really understand the electron side and the transmission of electrons and the transformers and the system design there. So when we looked at it, we're like, well, actually, we've got all of the engineering understanding, actually a lot of the technical and project delivery skills, and some of the operations and maintenance skills that kind of go with all of that already. The other thing that we bring that I think is being particularly valued by the customers in this space is our ability to take a project from its earliest kind of concept phase and kind of the sketch of, I'd like to make some e-fuels and I've got a bit of CO2 over here and I think I've got some sunshine and some wind, and be able to take that from concept into the kind of front-end engineering design, and then be able to say, well, we can build it for you as well. And actually, we're thinking about how we build it when we're designing it, and actually not just that, we can operate it for you. And again, a lot of these developers, customers, maybe they're coming from a utilities or renewable space, or maybe they're a cement business or an energy from waste business, and they've never had to run a hydrogen plant or a carbon capture, a chemicals plant, ultimately at the end of the day. And so there's a lot of new challenges with that.
So do you think that that hydrogen has a potential to disrupt the world's energy landscape now?
This energy transition is going to disrupt an awful lot of things that maybe we're not quite sure. We haven't seen that impact yet. We don't understand what that impact will be, but it's going to be a fascinating time to be around as the globe sort of remakes itself under this new energy map.
Yeah. I mean, it's a kind of democratization, decentralization of that energy system. we're already seeing some of those traditional energy players who've kind of realized how this is evolving. So the Saudis, the UAEs of the world, who are, their place in the world is as an energy exporter today. And they've kind of quickly realized, well, actually, we've got a load of sunshine, and in some places a little bit of wind as well. So, we can maintain our position in the world by leverage. They're lucky they've got, supply chains, resource base, an understanding of how to do these big energy projects. And so they're moving very quickly to try and get their position and ultimately maintain their position in the kind of geopolitical pecking order of the world, by kind of maintaining that energy export capability. But yeah, we're seeing countries, coming up in the world. The UK, who had, dropped off really as a kind of hydrocarbon producer, suddenly with the Saudi Arabia of wind. 25 gigawatts in one round in Scotland. There's 2, 3, 4 times that potential easily. So what are we going to do potentially with all those electrons? Suddenly we're in a much more interestingly kind of geopolitical position, potentially as an energy exporter again, which we've not had that kind of position since probably the early mid 70s.
And imagine if we don't have to import energy ourselves,
yeah,
again, right? So that has an impact on the government's finances, right?
Yeah, very much so.
My final question: you mentioned mobile phones earlier on, and I think my era, but I'll do it in 2 tranches here. So my era was the Nokia 3310. That changed the game technologically. And then for younger listeners, the iPhone changed the game again. Just so we can get both. I'm outing myself my age by saying Nokia 3310. But so there's that moment in history where technology changes the game. Is there anything like that on the horizon you see in hydrogen that's going to drastically change the market within the next 18, 24 months?
In the 18, 24 month window, I don't think there's anything that's going to be completely game changing. Really, it's going to be understanding, how do these projects become real, and then the game changer will be actually kind of seeing them come to reality. So the firming up of the commercial models, the financing models. So it goes from bits of paper to actually proper projects, steel, concrete in the ground that's actually producing electrons or molecules. And to a degree that will be game changing. People will start to think very differently once they see this become a reality, and they can go and kind of touch it and feel it, and then you get kind of comfortable with it. So actually it's not so difficult to produce or move ammonia around or methanol. Actually there were suddenly these hydrogen fueling stations popping up all over the place, and actually I can get really good range and performance on a hydrogen HGV. Actually, maybe I should switch my fleet over. And I think that kind of the realization of this, it kind of becoming a reality, will start to change attitudes and ultimately then kind of change behaviors. So I think in the short term, that's probably the biggest kind of impact I see, that it'll become real and suddenly people will really get behind it.
I think again, because it's an unlimited resource, solar and wind, and you look at these different suppliers, it's much more competitive, and I truly believe the cost will come down. And then you start to look at the cost of energy has been a traditional constraint in growth across the globe in every industry, right? So imagine if you've got really cheap, in some cases maybe free or close to free electrons nearby. A substation, they've got these things that turn into hydrogen, and they're going to sell it to you cheap, because otherwise it's just given away or curtailed. So what could you do? What manufacturing, what industry could you build up nearby those areas? And it might be somewhere near like Iberia or Namibia or Oman or somewhere, where if you think about the petrochemical industry, often in Saudi or places you'll have fairly cheap access to gas locally, and then they'll form a petrochemical plant next to it because they can get access to it cheaply, and then they start to produce high value products which they can then sell. So it might be plastic bottles or fertilizers or fabrics. Imagine that now with electrons or hydrogen. What industry, what growth opportunities are we going to see across the globe in new locations where the energy is really cheap? And I don't think that's going to come yet. You're right. I think we're right at the start of this change. But you go fast forward sort of 20 years, 25 years, I think fundamentally some areas of economic growth and this democratization of energy in a cheaper way should have huge growth potential for the human race across loads of ways. And we'll be doing it in a low carbon manner or a zero carbon manner.
Listen to you both speak today. It's actually made me quite excited, and I think the main word I'm going to take away from it is opportunity. Thank you so much for spending the time with me today.
Thank you, Darren.
Thanks, Darren.
Thank you for sticking around to the end. I really hope you enjoyed the conversation between myself, Alex, and John today. If you want to find out more about our new energy services, please head over to the website petrofac.com and check out our other episodes that we have available too.